So hi everybody. Pleasure to be here with you this evening. Hopefully I'm going to talk for less than 25 minutes because I'm sure you don't want like a big lecture. So my name is Paul Young. I'm a climate scientist. I work at Lancaster University and I live just across the bay in Morecambe actually. So maybe if I turn my light on and off quickly enough, you'll be able to see me. Anyway, so it's a great pleasure to be talking to you who are our near neighbours. So I'm just going to explain to you. Sorry, I've also got a bit of a sore throat, which is part of the reason why I don't want to talk for 25 minutes. So I will stop and have to just take a little swig of water every now and then. So I want to explain to you, just really give you quite a high level briefing of like what climate change is and how the climate is changing. And I think for me, like one really nice figure that illustrates this are these so-called warming stripes. So you can see along here these blue moving towards red stripes as we go from left to right across this image. And each of those stripes represents a single year temperature in the global average temperature from about 1850 right the way through to the present day. And the bluer the line is, the colder that year was on average, and the redder the line, the warmer it was on average. And I think you can pretty much see that the punchline there is that warmer years are appearing right at the end of this stripe, or right at the end of the record, which is the time where we're living now. So the world has warmed. It's got about 1 degree Celsius warmer since the Victorian times. So we've got lots of data and information we can take on temperature. We can look at other things as well, which I'll be happy to talk about afterwards. But one of the things that's really important is that this sort of one degree warmer since Victorian times isn't the same everywhere, and it's actually not even the same at different times of the year. So on the last slide, I showed you the picture for the whole world, and here we've got a map of the world, and again we're using colors. And this time we're showing where, what the temperatures are in the present day, excuse me, compared to the Victorian times. And the deeper the colors, the more purple is the warmer that they've got. So the thing that will probably really jump out at you here is the Arctic. So right at the top of the map up here, I don't know if you can see my pointer actually, there we go. So right at the top of the map here, that is a really, really large degree of warming. So more than 3 degrees. So the world on average is warmed 1 degree. The Arctic has warmed 3 degrees. And there's lots of important processes that have led to that, which I'm happy to talk about afterwards. What you might also notice is that the land areas have warmed more quickly than the oceans, or they've warmed more than the oceans. And that's because the oceans can absorb more heat without changing temperature, basically, so that the lands have warmed more than the oceans. Excuse me. So why has that happened? And basically, I think you can probably guess what the punchline of this is going to be, is that we have been putting greenhouse gases up into the atmosphere. And as we add these greenhouse gases to the atmosphere, the Earth gets warmer. So we can think, so the air, the atmosphere all around us is made of lots of different chemicals. Oxygen, hugely important for life on Earth. Nitrogen, and those are the two main components of the atmosphere, of air. But there are things that are present in much smaller levels, which are really important, just down to their chemical properties, their chemical structure, and the physical structure, which means that they absorb heat. And you can think of the greenhouse gases acting like a blanket on the Earth. So actually, without any greenhouse gases at all, the Earth would be uninhabitable. We'd have a temperature that would be 20 degrees below freezing, and liquid water would not exist, and there would be no life on Earth. But what we've been doing is unprecedented increase in greenhouse gases over a very, very short period. And we're adding to this blanket, and we're making the world warmer. And well, yeah, that is basically the picture. So there are other little subtleties to that about of the greenhouse gases that we put into the atmosphere, that we say that we emit, that we put into the atmosphere. About half of them stay up there, and the rest get absorbed by plants and trees, and also by the ocean. Excuse me. Sorry, I have to have a little swig. So we can also ask, where do all these greenhouse gases come from? And if we look at well, we can do an assessment as scientists and economists actually can work out, you know, what are all the different activities that we're doing, and how much are they contributing to the amount of greenhouse gases in the atmosphere? And if we were to think about the global picture, we get something that looks a little bit like this. Again, I'm not going to talk about this in a huge amount of detail, but just to give you an overview. So the biggest source, in least in the way that we've split it up here, is the production of electricity and heat. So globally, that's a hugely important source. Consumption and use of that energy in industry, the making of cement and buildings is another main source up in the top left there. And you also notice there's transport, both on the surface and also in the light blue, and down at the bottom in the purple. We can add to that flying and shipping. And then there are emissions that come from farming, from growing our food, whether that's plants or animals, and also whatever we do to land. So trees hold on to some of that carbon dioxide. Trees take that from the atmosphere, and if we chop down trees, then that acts as a source of carbon dioxide to the atmosphere. And then finally, we have this sector, buildings, so final energy use in buildings to heat and power our homes, and also the waste that we produce. So that's the global picture. We can also have a look at what that looks like from the UK, and you can see that we subtly change the size of these squares because they have different importance in different countries. And it just so happens that in the UK, our energy consumption in buildings and the waste that we produce, but it's mostly from the buildings, is quite a large proportion of all of our greenhouse gases. And also surface transport is comparatively more important as well. There are other things you might like to pick up on from there, but we haven't got time to go into the whole detail. For those that are interested, I can certainly point to where you can look at this data yourselves. One of the other things that's interesting to point out about where all these greenhouse gases come from is to think about who is responsible for emitting them. So we don't all emit greenhouse gases at the same rate. And if we look globally, we look at this picture that comes from an analysis from Oxfam. The richest 10% of people in the world emit half of all the greenhouse gases. So 10% of people emit 50% of all the greenhouse gases. And you can see how that decreases down here. So the poorest half of the world only emits about 10%. And the most recent number I could find, just for thinking about that in the UK, it's not quite the same inequity. It's not quite the same difference between rich and poor. But here we have the richest 10% emit about 3 times as much as the poorest 10%. So when you think later on, I guess in this process about things that might want to be targeted, these are sort of numbers that it's good to know and good to have in mind. So what will happen in the future to our climate really depends on the amount of greenhouse gases that we put up, continue to put up into the atmosphere. And as you can see, these are decisions that we make about how we deal with our buildings, our industry, how we produce our electricity and heat, how we get about and transport and things like that. And as climate scientists, we have various different scenarios for what the future might look like. And these aren't predictions of what the world will be like this, but they're stories really that we can tell about how things might be plausible futures, if you like. And there are different trajectories. So if we were to follow this dark blue line down here, we might we'd have low greenhouse gas emissions. And in fact, we'd actually be even getting towards zero greenhouse gas emissions. Then we might limit the global mean temperature rise above Victorian times to about 1.5 degrees. And this is a number you might have heard before as being really important in terms of managing some of the risk from climate change. So 1.5 degrees, it's still different from today. It's still, we'd still see worse things, but it's not as bad as it could be if we look at some of these other lines. So this light blue line, this orange line, and this red line, where greenhouse gas emission levels have gone up a lot more, and consequently the temperature is also a lot higher. So going up to even above 4 degrees above these Victorian times with this emissions here. I'm happy to say it doesn't look like we're on this trajectory, this storyline at all. In the minute, we're heading more for something like here. But if we're to limit risk, we really need to be heading for something down here. And this is something that all the climate science agrees on. Excuse me. I think I'm going to skip over that one and maybe just say something a little bit more about how climate change, the impacts of climate change and how they might be different over the world and how we might want to think about that. So let's imagine a world where the temperature, global mean temperature, is about 2.5 degrees hotter than Victorian times. And we can use our computer simulations, our very detailed models to make some estimates of what we think heat waves might be like in the future and how they'll be different over different regions of the world. And this map shows here the number of really of days of very deadly heat. So heat that is of a threat to life, and what we would expect from this world, which is like about 2.5–3 degrees warmer than Victorian times. And you can see that the impact of this is really concentrated in around the tropics, in a region that the developing world, where people who are not only less responsible for the emissions that cause this climate change, but also more vulnerable. So one of the things that we're definitely interested in as climate scientists is to try and quantify the impacts of climate change in this way, and think about, well, we can think about issues of justice and fairness, but we can also think about resilience, the capacity of different people to be able to deal with the shocks. Should also say that the science is really advanced, particularly in the last few years, where they've been able to look at extreme events that have occurred in recent times, and be able to assign them to climate change. So some of you may recognize some of these things from the news. So particularly here, but there was extremely hot temperatures in the Pacific Northwest, this region of America, but also going into Canada. And analysis that scientists have conducted is to say that this would be virtually impossible for an event like this to have happened without climate change. We could look to other events as well. There were massive heat wave in Siberia in 2020. It was made 600 times more likely with climate change, resulted in a huge breakout of wildfires across that region. Down here in Cape Town, there was a prolonged drought occurring there from 2015 to 2017, and that was made 3 times more likely by climate change. And up in the top right here, and this is an interesting one. So France this year suffered some frost damage to the crop that the grapes that are used to make wine. And the reason of that is that as temperatures have been getting warmer, the plants have been developing earlier in the year, but earlier in the year puts them at a risk of cold spells. So it's not that climate change had made it colder, it's just that climate change had made the plants come out when there was more of a risk of it being cold. Right, nearly at the end. So what we need to do to avoid the worst of climate change is that we need to get to what we call net zero emissions. So what this means is that any greenhouse gases that we continue to put up into the atmosphere, then we need to be thinking of ways that we're also taking out the same amount in the atmosphere. So that could be from planting forests, or it could be from some technological methods, some chemical or physical methods, where we take greenhouse gases from the atmosphere, but these have never been done or developed at scale. So the UK has done pretty well in the last 2 or 3 decades, as you can see from this light blue line here. Our emissions, so this is emissions per person per year, just so we can allow us to compare ourselves with the rest of the world. It has decreased by about half, actually, over the last 30 years, but we need to decrease half again over this next decade, and we have this target of reaching this net zero emissions by 2050. So the challenge is pretty big, but it's obviously something that we need to rise to. Last slide is just a quick summary for you. So sorry, it's a lot of text, but maybe I'll talk through it, and maybe we can just leave it up for 30 seconds or so, just as you're going for break. So I want you to the take home points I want you to get from this. The climate is changing. And it's definitely changed. I'm extremely confident of that, and it hasn't been the same everywhere. And that climate change has been caused by greenhouse gases that we've put in the atmosphere from our activities, from humans' activities. There are issues of equity and fairness here. The poor have contributed less to these greenhouse gases, but as I also showed, in many regions of the world, they stand to also have the most impact from climate change. The future is not written. It does depend on what we do with our greenhouse gases, and if we emit less greenhouse gases, if we put fewer amounts of greenhouse gases in the atmosphere, then the climate change will be less. The impacts of climate change themselves are not felt equally. It'll be in different parts of the world, but also will be different times of the year as well. And I also showed you some recent extreme events, and you can imagine how that they would impact different people differently, depending on how resilient they are, what infrastructure that they have. And maybe that's something we can talk about as well. And what we do need to know is that to avoid the worst of climate change, sorry, this last bit has run off the edge of the slide, we need to get to net zero emissions. Okay, so that's me. Thanks very much. I do apologize about my voice, and I hope you got something from this presentation.